So in this video we'll be learning about the root test. Now in my last video we learned about the ratio test, which is very similar to the root test. So we have, let's say, a series from n is equal to 1 to infinity, and what we do in root test is we take the limit of n is approaching infinity of that series, let's call it a of n, and we take it to the power of 1 over n, and we evaluate the answer. Let's denote this answer by L, capital L. Now this is the same as the ratio test. If it's less than 1, it is converging. If it's more than 1, it is diverging. And if it is equal to 1, it means that it is inconclusive, meaning that we need to try some other test to find the answer. So the properties of the answers are the same as the ratio test. So now let's start with an example. Let's take question number 1, the series of n squared over, let me write that bigger, n squared over 2 to the power of n, and n is equal to 1 all the way to infinity. And now let's start by writing the formula. So all we need to do is take this series, take the limit of the series to the power of 1 over n. So let's do that. So it was limit of n is approaching infinity, and we have the exact same thing, n squared over 2n, 2 to the power of n to the power of 1 over n. Now we need to use the properties of exponential to simplify this fraction that we have. So let's use those and distribute the power to the numerator and to the denominator. So it's going to be equal to n squared to the power of 1 over n over 2 to the power of n over n is equal to 1. So I'm just going to write 2 to the power 1, which is just 2. So now we can use the properties again of exponential and distribute this n, 1 over n, to this numerator. So that is going to give us n squared over n is over 2. And don't forget that we are having the limit of n is approaching infinity. So let's just write that over here. So now that's what we are left with. Now if we substitute n as infinity, we will get infinity to the power of 2 over infinity, and 2 over infinity is going to be 0, right? So it's basically infinity to the power of 0, which is an indeterminate answer, and we cannot have this. We don't know what is the answer, if it's 0, if it's 1, if it's infinity. So whenever we have this, we have to somehow simplify or evaluate this fraction some other way. And a way to get rid of these powers is to introduce ln into the question. So that's what I'm going to do here. But before we introduce ln, I'm just going to take this half outside because it's just more easier, and it doesn't really make a difference if it's outside or inside. So half limit of n is approaching infinity of n to the power of 2 over n. Okay, let me just write it again, n to the power of 2 over n. So now I'm going to replace this part, limit of n to the power of 2 over n, with limit of ln n to the power of 2 over n. Now don't forget that once we introduce this ln, we, in the end, whatever answer that we get, we are going to do e to that answer to get rid of this ln, because we can't just introduce a ln randomly, right? Because ln and e cancels out. So if we are introducing ln here, we need to reintroduce e in the end of whatever answer that we get. That will be more simpler once we simplify, so let's do that. So now we have limit of ln n to the power of 2 over n. Now as we know the properties of ln, we can take the powers down to the coefficient. So now let's simplify it. I'm gonna scroll down a little bit, and we can take the coefficient down as we mentioned before. So it's gonna be 2 over n multiplied by ln of n, and this entire thing is limit from n is approaching infinity. And actually I can rewrite this as 2 times ln n over n. Now if we substitute n as infinity, we have the numerator ln n, which is also infinity because ln infinity is infinity over infinity. So we need to apply the L'Hopital rule here, which is basically deriving both the numerator and the denominator. So let's do that. So the derivative of ln is 1 over n. So here I'm gonna get 2 times 1 over n, which is the derivative of ln n, over the derivative of n here is going to be 1. So we have 2 times 1 over n over 1. So now if we substitute n as infinity, we will get 2 over n, which is 2 over infinity, which is equal to 0, divided by 1 over here. 0, 1 is also 0, right? So we get the final answer as 0. So now we have this part that we introduce ln as equal to 0. So now how do we get rid of this ln so that we can go back to this question? As I mentioned before, we can take e. So we need to take the answer e to the power of the answer. So e to the power of 0 is equal to 1. So this part over here, this part over here is equal to 1, and we have a half outside, so it's going to be half multiplied by 1, which is half. And half is less than 1, meaning that it is converging. So once again, let me just erase so I just want to write a note. If you are introducing ln in your answer to be able to simplify whatever powers or exponentials that you have, in the end, whatever answer that you get over here, let's say it is in our case 1 or 0 or whatever, we have to take e to that power of that answer. So e to the power of 0 or e to the power of 1 always, because you can't just introduce a ln and leave it there. You have to cancel that ln with e, because e to the power of ln of anything, let's say a, is equal to a, since e and ln cancels out over here. So one last thing that you should be very careful of is we do have 1 over 2 outside as a coefficient of this limit. Now once we introduce ln, we had 2 over n, but we cannot cancel this 1 over 2 multiplied by 2 over n, since this part we have introduced a ln, and you can think of this like this entire part was equal to a function, and once we introduce this ln, it becomes a completely new function. Let's call it b, and that is why we cannot cancel this half with 2 over n. And this 2 over n, this 2 actually is under the influence of actually 2 to the power of e to the power of 2, sorry. Now this exact same question, you can also solve it using the ratio test, and you will get the same answer. So it depends on you, whatever method is more easier for you. So our next question is quite similar, so you can pause the video and try to do this example yourself. So we have 2 to the power of n over n cube. So once again, the formula is you take whatever equation or series that's given to you and you raise it to the power of 1 over n, and you take the limit of n is approaching infinity. So let's write that down. So you can take this moment to pause the video and try to do this and then compare your answer. So limit of n is approaching infinity, and we have 2 to the power of n over n cube to the power of 1 over n. Now let's distribute the powers. So it's going to be 2 to the power of n over n, which is going to be 2 to the power of 1, which is just 2, over n to the power of 3 over n. And once again, to be able to simplify this, we need to introduce ln. So what I'm going to do is I'm going to write this 2 outside actually. So here is going to be 2 limit of n is approaching infinity, and then we have 1 over n to the power of 3 over n, and also we can actually bring this up, so it's going to be n to the power of negative 3 over n. It's just more simpler. And now let's introduce ln. So let me just make this closer, and so now it's going to be limit of n is approaching infinity, and we have ln of n, so there's 2 n's over here, just be careful of that, negative 3 over n. Now we can bring this negative 3 over n below, so it's going to be negative 3 over n ln n. And now let's apply the L'Hopital rule. So it's going to be negative 3 of derivative of ln n is 1 over n, and the derivative of n here is just 1, right? So now we are left with negative 3 over n, and as n is approaching to infinity, we have this negative 3 divided by infinity is just 0, so we have 0 as our equal to whatever this part is. Now to be able to get rid of this ln, we need to get the answer to be the power of our e. So e to the power of 0 is equal to 1, so this part over here is equal to 1. Now we have 2 outside, so don't forget about that. 2 multiplied by 1 is equal to 2, which is more than 1, which means that it is diverging. So you might be thinking, when does this test, the root test, comes more helpful or more useful compared to the ratio test? So here's an example of that question. So question 3, we have a series of n is equal to 1, infinity, we have 1 over n plus 1 to the power of n, and if you apply the the root test here is going to be limit of n is approaching infinity, and we have this entire thing to the power of n and to the power of 1 over n, and here these two cancel out, so all we are left with is 1 over n plus 1, and this means that it is 1 over infinity, which means 0 less than 1, meaning that it converges. Now if you do the same exact question with ratio test, you gonna get very complicated and it's gonna take a lot of time. So this is when the ratio test comes in more helpful or more handy, whenever you have exponentials to the power of n, and whenever you see factorials, that is when ratio test comes in handy. So keep in mind, whenever you see factorials, try to use ratio test, and whenever you see that exponentials are to the power of n, you have to use ratio test, or sorry, root test. I keep mixing the names, because as you can see here, whenever you have anything to the power of n, we can just cancel that out with 1 over n, right? So it comes in really helpful for that. So now let's do another example where our root test does not work. So question number 4, I think, and the question is 1 minus 1 over 3n to the power of n, and n is equal to 1 and goes all the way to infinity. So just try and pause and try to do this yourself. We're gonna get 1 minus 1 over 3n, limit from n is approaching infinity, and this entire thing is n to the power of 1 over n. These two cancel out, so we are just left with 1 minus 1 over 3n, which is equal to, as n is approaching to infinity, we are going to get 1 minus 0, which is equal to 1, which is equal to 1, meaning that it is inconclusive. So here's an example where the root test does not work. So what can we do over here? what we can try here is called the nth term test. So, and also we need to use len here to get rid of this exponential. So let's do that. We are gonna get limit of n is approaching to infinity, and we have len of 1 minus 1 over 3n to the power of n, and here we are bringing the n down, so we are gonna get n len n and this entire thing. Now our end goal here is to be able to use L'Hopital rule, and L'Hopital rule is only applicable when we have fractions like a over b, then only we can use L'Hopital rule. So here what we can do with the n here is, as it was in the numerator, we can bring it down and rewrite it as n to the power of -1. So now we can use L'Hopital rule. So let's do the derivative of the denominator first, as it's more simpler. We are gonna get negative n to the power of -2, and deriving the numerator here is quite complex since we have to use chain rule plus the derivative of len here. So the chain rule first is whatever we have inside, we just rewrite it. So it's going to be 1 minus 1 over 3n multiplied by the derivative of the inner part. So here the derivative of 1 minus 1 over 3n is equal to 1 is just going to be 0, like 1 over here, 0, and to derive -1 over 3n, we are going to bring -3n above, and this is going to be -1, and when we distribute the power, it's going to be positive 3n, and you have to minus 1 from here, so it's going to be 3n to the power of -2. So we are going to get 1 over 3n squared, since it was positive 3n to the power of -2. I just brought this down. And now if you notice something, we can cancel the denominator with this n squared over here, since if we bring this up, it's just going to cancel this part out, and the negative sign I'm also going to cancel it out and just bring it up. So our final thing, actually let me just leave that over here and I'll just cancel it in our next writing. So we are going to get limit of n is approaching infinity, and we have -1, since there was a negative sign over here, over 3 to the power of, multiplied by 1 minus 1 over 3n. And now let's simplify this. So as n is approaching infinity, we know that this part is going to be equal to 0, so all we are left with here is -1 over 3. And remember that we took a len at the start, right? So we need to equate this to the power of e. So e to the power of -1 over 3 is not equal to 0, meaning that this nth term test diverges. So that's all for this video. I hope that you understood this, and if you have any questions or any doubts, you can always ask in the comment section. I'll be more than happy to answer, and thanks for watching.